Welcome to recursive functions and finite differences. So all we're going to talk about today is a different way to write a pattern. First thing, we need to look at some notation. We see our f of stuff again. So what you see, f of 0, anytime you see that, that's representing the first term in your pattern. If you see f of n minus 1, that is your term before, and f of n minus 2 gives you two terms before. So you're going to see that notation in some equations. So first thing we see here, given the function, my recursive function down here, we want to evaluate f of 5. So what the number inside the parenthesis mean is what term number I want to find. So the easiest thing is to make a table. So I'm going to make a table, start at 0, and I want to count all the way up to 5. So 1, 2, 3, 4, 5. Please remember the f of 0 is 2 because that's what it tells me f of 0 is. So that means when you plug in 0, you get 2. What the notation here means. That, if you remember from the last slide, means the term before. So all we're doing is taking the term before and we're adding 1. So if I want to find this number, I take the term before, which is 2, and I add 1 to it, which would give me a 3. Next one, if I want to find this answer, I take the term before and add 1, and that'll give me 4. Then this one, again, I add 1, so 4 plus 1 would give me 5. Then I keep adding 1, so they give me 6 and 7. So what that means is f of 5 equals 7. What this is also going to help me with later, since I organize this in a nice table, is it represents coordinates to write an equation. So I have the coordinates 0, 2, 1, 3, 2, 4, so on and so forth. So let's go ahead and try another one of these. Again, you see, we want to find f of 5, given this new recursive definition. So I want to make the table and count up to 5. But in this case, it gives me f of 0 is negative 1, and f of 1 is 3. Now why it gives me 2 is because my recursive over here, if it has n minus 1, remember that's your term before. And if it has the f of n minus 2, that means 2 terms before. So I'm going to take my term before and I'm going to multiply to my 2 terms before. So if I'm trying to find this number, I take the term before, which is 3, and multiply it to the one before that, which is a negative 1. So I'm getting 3 times negative 1, which would give me a negative 3. Now I got to get the next one. I'm taking the term before this box and multiplying to the term before that. So that would give me my negative 3 times 3, which would give me 9. Then to get this one, I take the 2 terms before that and multiply. So now negative 9 times negative 3, which would give me a 27. And then the last one, I need to take 27 times negative 9, which would give me a negative 243. So that's how you take recursive notation and you get a pattern out of it. Now, what's also important is when I take this and I want to write an equation for it. So to figure out the pattern, first today we're going to talk about, is your pattern linear, quadratic, or cubic? So what we do is we find what we call the first and second differences. So when we write down the pattern, what is the pattern? Do you keep adding the same number? Do you keep multiplying the same number? And so what it means, if you look at the pattern, if you keep adding or subtracting the same number, that's linear. So that's what I mean. The first time you subtract the numbers are the same, then it's linear. Now, if there's a pattern in your pattern, so if your pattern keeps increasing by 1 or decreasing by 2, that's going to be quadratic. And then if you subtract it a third time, that's going to make it cubic. So let me show you what I mean. Here's a table. If you remember, your pattern is always determined by your y values. Now we're always going to subtract these. So I can see, obviously, I don't keep adding a number, but I'm going to go ahead and do 16 minus 2, which would give me 14, 54, minus 16, which would give me 38. 128 minus 54 is 74. 250 minus 128 is 122. 432 minus 250 would give me 182. So those are not the same. If those were the same, it would be linear. So now I want to see if there's a pattern in these. So do 38 minus 14 is 24. 74 minus 38, 36. So those aren't the same. 122 minus 74 would be 48. Okay, that's enough to be able to figure out if there's a pattern here. This determines if it's linear, if they're the same. This one determines if it's quadratic. Now if I subtracted a third time, that'd make it exponential. So 36 minus 24 gives me 12. 48 minus 36 gives me 12. So those are the same. So that tells me, I'm sorry, not exponential, this would be cubic. So the pattern here is cubic. So this is known as your first difference, then your second difference, and your third difference. Last thing we're going to do, we're going to put both of these together. I'm going to give you a recursive function, then we're going to determine if it's linear, quadratic, or neither. So again, we're going to start off with the table. We'll probably go up to 5 again. 1, 2, 3, 4. Well, this time it tells me f of 1 is 0. Well, that's something different, but it doesn't matter which one we start at, so I don't need f of 0. Let's go ahead and add on the 5 down here. So if it's 1, it's 0. Remember, this is your term before. Now this is a little bit different. It has n, which is your term number. So if I want to find term number 2, I'm going to take my term before, which was 0, and I'm going to add 2 times that term, which would be 4, so I get 4. Then, again, I take my term before, which in this case was 4, then plus 2 times my term number, which would be 6, so this would be 10. Take my term before, which is 10, plus 2 times this term number, which would be 8, so it's 18. And then my term number before would be 18 plus 2 times the term number, which would be 10, so it gives me 28. Well, my pattern in here, I get a difference of 6, 8, and 10. I know here has a difference of 2, so since my second difference was the same, this would make it quadratic.